Well, ahoy, pirates. We are jumping into 3.3, which is about function notation. So if you want to pause and take some notes, here's the vocab we're going to be using. But let's jump right into it. So function notation is basically you're just going to replace the y with, it's called f of x. So when you see this right here, let me zoom in a little bit. Ooh. There we go. Okay. So when you see this right here, wait, there we go, this f of x, that doesn't mean f times x. It's called function notation. And sometimes this f will be a different letter. So anything you want to add to that?
The x can also be a different letter. T is usually used for time.
Oh yeah, that is true. All right, so a lot of times instead of just having a single variable y, like y equals mx plus b, you'll see this instead, and that is function notation. So again, this is another good spot to stop and take some notes. Okay, now that you've taken notes, hopefully, we're going to jump into an example. All right, so you're going to evaluate f of x equals negative 4x plus 7 when x equals 2. So what that means is x is your input. You're going to plug 2 in for x, and then f of 2 is what you're trying to find. So did I state that correctly, do you think?
Yes.
All right, so figure out what y is. What is our output when x is 2? All right, so hopefully you did negative 4 times 2, and then added 7, and you'd find out that f of 2, wow, here we go. Oh, they already did the other one too. Sometimes this is why I should click through before. So yeah, f of 2 is negative 1, and then I accidentally clicked through the other one also. So when x is negative 2, you plug in negative 2, and you find out it's 15. Okay, so there we go. Moving on to this next example. All right, so here we have f of t. So, and t, it stands for hours, time. Good call on that one. It's not always x. So f of t is the outside temperature in Fahrenheit. T hours after 6 a.m. So what is this first statement here? F of 0 equals 58. What does that mean? Okay, it means because the 0 time is 6 a.m., it means that the temperature at 6 a.m. was 58 degrees Fahrenheit. All right, the second one, what it means is f of 6, that's 6 hours after 6 a.m., so that means the temperature at noon is n degrees Fahrenheit. And then the last one, f of 3 being less than f of 9, what does that mean? Okay, it actually means that the temperature at 9 a.m., which is 3 hours after 6 a.m., is less than the temperature at 15 a.m. There is no 15 a.m., so it's 3 p.m., because that's 9 hours after 6 a.m. Or I guess you could say 1,500 hours if we're doing military time. Okay, and then Ms. McCracken, you want to take this next one here?
Yes,
okay.
So this question is asking you to find what x is when your f of x equals negative 7. So negative 7 is your output, so what is your input? So why don't you get a piece of paper and see if you can figure out what x equals when h of x equals negative 7.
All right, let's see how you did. So hopefully you wrote down the function, and then you're plugging in negative 7 for your output and solving it. And hopefully you got negative 3. Okay. And we got to talk about how to graph. So if we're going to graph this function, f of x equals 2x plus 5. 2 is our slope we talked about, our rate of change. 5 is called the y-intercept. And we're going to talk more about how to graph these just from the equation soon. But the way we're going to do this is to make an in-out table. So a lot of times you'll use some negative values for x and some positive values for x and a 0, because those are good representative values as inputs. And then we got to figure out what the outputs are. So here it's saying plug in negative 2 for x. What is the output when x is negative 2? Okay, it is 1. So if you do 2 times negative 2, that's negative 4 plus 5 is 1. So if you fill out the rest of them by plugging in these different inputs for x, this is what we get. And then we would put these on a graph. These all represent ordered pairs. So this first one of negative 2, 1, just a quick refresher, we go back 2 and up 1. So our first dot would be right here. And then negative 1, 3 is here, and so on. So that we plot the ordered pairs. would this be discrete or continuous? And remember, we could have plugged in any values we wanted for x. Okay, so this one is continuous. So you'd have to draw a line through the points because we could have plugged in like negative 2.1 or 1.36. So all of these values we could plug in and get an output. So that one's continuous. And that's our graph. Okay, and we have this real life example. So take a second to read this over. Okay, now that you've done that, the way we're going to solve this is always understand the problem and make a plan. So a good way to graph this situation is to make a table. And because it doesn't make sense to have negative time, we'll just start at 0. So it doesn't make sense to have negative x values for inputs here. So for this equation, when you plug in 0 for the time, number of hours, what is the distance? What is the destination? So the destination distance is 350 miles. And then when you plug in 1, 225, and you'll notice it's going down 125 every time. So that is actually our slope. That's our rate of change. The number next to the x, our m, which is negative 125, is how much it's changing every time. So then when you graph it, you end up with these points right here. So again, for this helicopter, are these discrete or continuous points? This is continuous because the helicopter travels the whole time. It doesn't, like a spaceship, you were saying?
Yeah, it doesn't jump around like a spaceship could.
Yeah. All right, so that is how you graph it. Okay, so what this negative 25 doesn't mean that it's like it flew past its destination. So at some point it would have stopped, and that is going to happen between 2 and 3 hours. It would have hit 0 distance from the destination. So try to solve that. Try and figure out, when does the helicopter actually arrive? And let's go back to that equation again real quick. So use this equation. You're trying to find out when f of x is 0. So what does x have to be to make f of x 0? Okay, so hopefully you set up an equation to solve it. And here you're making the output 0. And when you solve it, you find out it is 2.8 hours. That's how long the helicopter takes to reach its destination. Okay, that's our video. Woo! If you have questions, ask us during class, or feel free to email me. Good luck, and we'll see you in class. R! Oh, we got an R.
Oh, R.
Woo! Okay.